series of videos to talk about eigenvalues and related stuffs. That is what I thought that maybe kind of a cheat code. So to start off with the first one, okay, is that this type of questions. So you are given this matrix 3 by 3 and one possible, and you're asked to find the unknown of this beta, where you're given one possible value that is eigenvalue that is 3. And in this video, I assume that you are not very familiar with the eigen method, so I'll just go through the principle of it and then we continue from there. If you are professional in it, then you can just skip to the somewhat the middle part of the video and you just try to check it out of how to find these unknowns. Otherwise, you just skip this whole video and go to the next video. Alright, so to start off, I recommend this equation, which is what is it? The homogeneous equation. Homogeneous means that when it is equals to 0. Alright, this is just simply that. And then lambda I, this is identity matrix where it's 1 1 1 0 0 0 of the rest. Okay, if you remember. So the lambda itself multiplied with I is simply lambda lambda lambda, the rest is 0, and then minus whatever things is over here, okay, is equals to 0. So we're gonna make use of this concept to help us determine what the fuck is this. Alright, to start off with this, I would write down, because since I know that previously, okay, never mind, no previously, so what I want to go and start off with, it's lambda minus, so lambda I, which is one of the lambda, minus a, which is part of this, so it's lambda minus 2, and then lambda minus, okay, for neat purposes, I think I just rewrite this. Alright, so this is the lambda I, and this is the A matrix that I'm talking about. So what I can do is to a method of what I always would start off straight away when doing this type of questions is to straight away write down, maybe I just write 2.1 because it's part of this step. So lambda minus 2, so it's this thing minus away this thing, I hope you remember, and then 0 minus minus 2, so I have plus 2. So the first thing first, normally I will do is to fill up all the lambdas. So as you can see, I can fill up lambda minus 2, lambda minus 1, and lambda minus 3. So I fill up all the diagonal in this manner, right? And then I keep all the rest of the value, and then this is the bracket. Alright, so I haven't finished yet, please be careful. So after which, so the first step is I fill up all the diagonal lambdas, right? And then the second step is to fill up all the rest of the numbers the same, okay? And then the third step is to change their sign. So I have plus 2, minus 2, minus 1, minus 8, minus beta. Okay? So we have this thing coming out over here. So it's just a flip, alright? So 0 minus minus 2 is actually plus 2. 0 minus 2 is actually minus 2, and things like that. So I hope that it's pretty clear. And since our purpose is only to solve for it's only to solve for beta, and we are given the eigenvalue of 3, we can straight away sub it into this thing, right? So when I sub it in, I have this matrix over here, okay? Then I would simply copy this, or if you are writing in pen, you can just do the same thing as this, and then applying the rules of Sores, where the rules of Sores states this thing, go in this manner. The orange color, the sum of the orange color minus away the sum of the blue colors. Okay, that would be easier. Alright, so when I do this, what do I have? I do together with you. So 1 times 2 times 0 is 0. 2 times minus 1 times minus beta, it's plus 2 beta, plus minus 2 times 0 definitely is 0. bracket, and then I minus away the blue colors one. So minus 2 times 2, I have minus 4. Minus 4 times minus beta, I have plus 4 beta. And then minus 1 times minus 8 is just 8, so I have plus 8. And then this is simply 0. And then I can rearrange. I would have 2 beta minus 4 beta, which is equals to 2 minus 2 beta plus 8. Minus 8. It's equals to 0, right? And then equals to 0 per meaning is because determinant equals to 0 means that they are so if its determinant is equals to 0, this means that that is a non-trivial solution. Later on we'll talk about it, but in this case the non-trivial solution states that this system is a unique system, okay, where it has only a value for minus beta. It has only one value for minus beta and nothing else. Alright, so there is only one value. If you have many values for beta, then it's not non-trivial, it's actually a trivial solution. And trivial itself simply means that it is like a useless stuff, you know. And see, trivial is of little value or importance, and that's the meaning. So if it's non-trivial, this means that it's important, that's all. Okay, and that's simply the case itself. And if we head back here, we have minus 2 beta is equals to 8, so I will know that beta is equals to minus 4, and that's the value of minus 4. And we have the answer to solve for what the hell is beta. So this is generally the one type of questions that they will ask, right? I call this a type 1, alright, a type 1 of questions, exam questions. So I'll see you in the next video for the type 2 exam questions that they will ask. I shall see you there.